about area between the regions. Now, if you are asked to find the area of between the two curves, then let's see how can we evaluate the areas. So our success criteria is to find the area of the region between the two curves using integration. Find the area of a region between intersecting curves using integration, and describe integration as an accumulation process. So here you can see the graph here, uh, this graph. Okay, look at the figure, this one. What have you seen? That there is a curve which is F, and there is also a curve that is G. And you are asked to find the area between the curves and the curves of the shaded region. Only from here till here you have to find out the area. And we know that the area can be found by integrating the equation or the function. But when you are asked to find the area enclosed between the two curves, then keep your eye over here on the top, and you see that what curve comes first. Yani you can focus which curve do you focus first. So you can say that I focus this dark black curve first, and the name of this curve is F. So as we are finding the area, it means we are going to evaluate the integrals. So upper region or the top curve, that is named as F, minus the bottom curve that is named as G. Okay. Now after that you have to find out that what are the upper and the lower limits. So since you are asked to find out the area of this pink region, then the lower limit is A, and the lower limit or the upper limit of the same function is B. Since you are taking the x values and the equation is written in the form of y equals to f of x or y equals to g of x, so you will apply here d of x. You will write d of x. So look at the figure one more time. So if we keep our eye on the top, the first curve which you focus is y equals to f of x. So you will say that the top curve minus the bottom curve, because the bottom curve name is y equals to g of x. Now, since we are writing f of x minus g of x means x, so you will write here dx. And you will take the x values as the upper and the lower limit. So the first lower limit of this area is x, is a, and this is your b, which is the upper limit. Now look at the second curve. If you, as I said, keep your eye over here, okay? So if you keep the eye over here, so can you recognize that which curve is on the top and which curve is on at the bottom? No, of course no. So for that purpose, you will keep your eye on the right hand side. On the right hand side. Now focus. Can you recognize what comes in the beginning? It means what comes at the right side, that is x equals to f of y. So that is f of y minus what is at the left curve, what is on the left side. So left side you have a red line, okay, red line curve, and the name of this curve is g of y. Now since we are writing y, so we will write d of y. And remember that whenever you take the right minus left, the equation must be written in the form of x equals to something, x equals to y. Means x is the dependent function and y is the independent function. Okay, so since you are taking the y, you will write the dy, and of course you will take the y values as your upper and lower limits. So here normally the students make the mistakes that they write the y dy, but they take the x value. So you have to make sure that you are taking the y values as your upper and the lower limit. So this one, the y values, named it as C, and the upper one, the name is D. So these are the two formulas through which we will integrate or find the area of the shaded region. What are the general strategies of the area between the curves? You have to sketch the curves first in order to find whether you are going to apply the top minus bottom formula or the right minus left formula. After that, whatever the expression is written on the top, you will write first, then minus the expression that is written on the left, you will write that one. So if the equation is written in the form of y equals to something, that is f of x, it means y is the dependent variable and x is the independent variable. Then of course within the integral sign you will write d of x and you will take the x values as the upper and the lower limits. Now if you graph and the graph doesn't tell you that you have to keep your eye on the top, then you keep your eye on the right side, and in that case you have to write f of y minus g of y, which means the curve which is written on the right should be written first and then subtract minus sign and then the left curve. Now once the y is the independent variable, you will write dy and make sure that you are writing the y1 and the y2 as the upper and the lower limits. After that, integrate by using the integration formulas, and that then find out calculate the values, and you will find in this way the area of the curves. Let's have a look at this question. Find the area of the region bounded by the graphs. F of x equals to x square plus 2. In your graphic calculator, go to the graph option menu and then the graph option. In the graph option, it would be written y equals to or y1 equals to or y2 equals to and so on. So first of all, for the y1, you write x square plus 2. You will see the curve appears. So label the curve as y equals to x square plus 2. Labeling is important. The reason is otherwise you will forget that what curves comes first and what comes at the bottom. After that, scroll down the equation and write your second equation, that is negative x here. You will see that y equals to negative x will be a line whose slope is negative. Now they are asking you to find the limits, yani find the area bounded between 0 and 1. So here of course this is the 0 and this part is your 1. Shade those part. Now you have to find the area of this region. Look at this. I can keep my eye here and can recognize very easily that on the top I have x square plus 2 curve and then minus at the bottom I have negative x. Since I am writing all the equation in the form of x, so I have to write the dx. And the limits are already given in the question, that is from 0 till 1. Make sure the smaller number goes in the lower limit and the bigger number goes in the upper limit. Now open the bracket first and solve. X square plus 2 plus x dx. You cannot solve more. Then take the antiderivative. We use the power rule, that is x cube over 3. We add 1 in the power plus constant rule. It means you add the x if there is a constant. Then again power rule, that means x to the power 2 over 2. Put a straight line from 0 to 1 means now you are ready to apply the limit. First of all, apply the upper limit minus the lower limit. So the upper limit is your 1. So replace x by 1. So 1 cube over 3 plus 2 times 1 plus 1 square over 2. Then the lower limit, so it will be 0 cube over 3 plus 2 times 0 plus 0 square over 2. Now calculate. Either you write all this equation in the calculator, or if you have the scientific or graphic calculator, then write this thing as it is in the calculator by pressing the option in the scientific calculator near the calc, this option. You write the question and get the answer directly. Make sure that your area should be positive. If you are getting a negative answer, so maybe you applied the limits in the wrong way, or maybe you wrote the curves at the wrong sides. So if we keep the eye over here, you can see there is a top curve and there is a bottom curve. Now the top curve is the blue line, that is square root of x, minus the bottom curve is represented by a red line, that is x squared. Since this is x and x, so we will write here dx. Write the lower limit. So here the value of the x is 0. And here the point of intersection, the value of x is 1. Now solve it. So we know that radical x has a power x to the power half. So before taking the antiderivative, write this radical sign in the form of exponent. So now add 1 using the power rule. So you will get 3 over 2 over 3 over 2 minus add 1 used as like in power rule. So 2 plus 1 is 3 over 3, straight line from 0 till 1. Now 1 over 3 over 2, it gives you 2 over 3, x to the power 3 by 2 minus x cube over 3 from 0 till 1. Apply the upper limit, means replace x by 1. And then apply the lower limit, that means write the 0 in place of x. So it will be 2 by 3 minus 1. The answer will be 1 over 3. You can use your calculator, as I said, either write these things all in the calculator without making the mistake, or write this thing to make sure that you are writing the correct thing. Now look at this question. Okay, this question, if you keep, because this is the shaded region, the blue one is the shaded region. If you keep your eye over here, you can easily recognize what is at the top and what is at the bottom. So this is your top. So the equation of this curve is square root of x plus 1 minus the line, the formula is x plus 1. The function is x plus 1, and then write the dx from negative 1 till 0, because we always take the points of intersection in the graphs. Now take the antiderivative, but before taking the antiderivative, it is important to write the radical sign in terms of exponent. And make sure that your functions are opened outside the bracket sign. Now look at this. This is x plus 1. Okay. Now, and there is a power. So if I write here x plus 1 whole to the power half. So this is the composite function, and you can use the U substitution method. The derivative of x is 1, which is written over here. So if the composite function is written and its inner function's derivative is written beside it, then we can use the power rule of integration, which means that write the bracket as it is, the inner function, add 1 in the power, so it will gives you 3 by 2 over 3 by 2. Now this one as a normal power rule, so it will gives you x square over 2 minus constant rule, that is add x, so it will gives you negative x. a straight line, you are ready to apply the limits. But before applying the limits, we know that 1 over 3 over 2 gives you 2 over 3. X plus 1 whole to the power 3 by 2 minus x square over 2 minus x from -1 till 0. Now apply first the upper limit, that means replace x by 0. So you will get 0 plus 1 to the power 3 by 2 minus 0 square over 2 minus 0. So you will get 2 by 3 over here minus 0 square over 2 minus 0. So you will get 0. So this is your upper limit minus, then you have a lower limit, that is 2 by 3 minus 1 plus 1 whole to the power 3 by 2, that would gives you 0 minus 1 whole square over 2 minus 1. So it will gives you -1 over 2 positive 1. So it will give you half. So it will gives you half. And then you can say this is 4 plus 3 by 6, that is 5, 6, 7 by 6. But check in your calculator if 7 by 6 is the correct answer. I don't know my calculation is right or wrong. So you just check with the help of the calculator. And one more thing, that if you write this in the calculator, the answer must match the final answer. Now look at the question. If I keep my eye on the top, I cannot recognize what is on the top and what is at the bottom. And also, a second hint is that the equation is written in the form of x equals to, it means x is the dependent variable. So I have to use my right minus left formula. So for that purpose, I have my right, means I have to keep my eye over here. So I can say that the blue curve comes at the right place. So the equation of the blue curve is -y square plus 10 minus, on the left curve is shown by the red line. So it is y minus 2 whole square. Since all the functions are written in the form of y, so we have to write the dy and take the y value. So the y value over here, if we see, it is -1, and the y value over here, it is 3. Now, since you no need to open this function, the reason is here we can apply easily the u substitution method. The reason is that the derivative of y is 1, which is written beside it. So if a function is written with its derivative, then we can easily apply the power rule of integration. So take the antiderivative over here using the power rule. So you will get minus y cube over 3 plus constant rule, that will add the y, minus now power rule along with the u substitution method. So you just add 1 in the inner function's exponent and same number over there. And after this, you know how to apply the limit. So upper limit minus lower limit and find out the answer. So here is another question. That means that shows also that you have to use the right minus left formula. So on the right, you have a green curve, that is 1 minus y square, minus on the left, I have the red curve, that is the function is y square minus 1. Since all the functions are written in the form of y, so you have to write the dy and now take the y value. So the lower value is the -1 and the upper value is 1. Now open the bracket first of all. We will get 1 minus y square plus 1 and dy. Now 1 plus 1 you will get 2. Minus y square you will get -2 y square dy from -1 till +1. Now apply the power rule normally. So constant rule, add y, so you will get 2y, minus power rule, add 1 in the power, so you will get 2y cube over 3 from -1 till +1. Now apply the limit. First of all, the upper limit and then the lower limit. It means wherever you have the y, first of all substitute by the 1 and then substitute -1 for y. So here is another question. So in this question, they again up right minus left. So what is the right curve? It is the blue line, that is y plus 1, minus left curve, the red line, that is half y square minus 3. Don't forget to put the brackets. Now you have the upper and the lower limit. So the lower limit for the y is -2 and the upper limit is 4. And you have to put dy. Open the bracket before applying the rule of integration. So it will gives you -half y square positive 3 and dy. Now we know 1 plus 3 gives us 4. So 4 plus y minus half y square dy from -2 till 4. Use the constant rule, you will get 4y plus y square over 2 minus half y cube over 3 from -2 till 4. Now apply the limits and get the answer. Hope you understood these kind of the question and the concept is clear that when can we use the top minus bottom questions or when we use the right minus left curves formula.